Hi, this is Sean Chua. Welcome to simplecemconcepts.com. Today I'm going to discuss with you a very important chemistry concepts. Alright, it's known as the writing of the chemical formula of ionic compounds. This is important because whenever you are asked to write a balanced chemical equation, you must first get your chemical formula correct first. Alright, now there is a method, we call it the X method. My students like to call it the X-Men method. Now, how do we use it? Let's use live examples to discuss. Let's move to the left hand side. Okay, for ionic compound calcium fluoride, what we do is we need to identify which are the cation and which are the anion. In this case, the cation will be Ca2+, and then the anion will be F-. So what we do in the cross method is this. We will so-called copy down the two formula, so it's Ca and F, put them very close together, and then we will circle the number in front of the charge. In this case, there's no number, so it's 1. And then you will cross them diagonally, and for the number, you just put them as a subscript. So in calcium fluoride, CaF, Ca will have the subscript 1, and then fluorine will have the subscript 2. Right, but this is not the overall or the final chemical formula yet, because in chemistry we don't like to show the value 1. So the actual chemical formula will be CaF2. Alright, let's move on to another example so that I can get you more confident. This is known as magnesium oxide. So the charge and the formula of the ions will be this: Mg2+, O2-, and similarly we'll do the same thing, put Mg and O very close to each other. We'll then circle the number in front of the charge, in this case 2 by 2. So if you do a diagonal translation, you have a 2 here and you have a 2 here. Now, over here I need you to know that in chemistry we also don't want to have very big numbers. We always go for the lowest common multiple. So we need to simplify to the simplest ratio, which is Mg1O1. And in chemistry, again, we don't like the number 1. So the final answer for MgO, magnesium oxide, will be this. Alright, we have 2 more examples which are slightly more challenging, and I want you to learn it very well in order to get very confident in writing chemical equation. This is known as iron 3 oxide, and the formula will be this for its positive ions, Fe3+, because 3 refers to the Roman numbering. It refers to 3, so it's 3+, and this is O2-. So doing the same thing, we'll put them very close together. We'll circle the number in front, and then we do diagonal translation. So this is Fe2, this is O3. So the formula will be Fe2O3, since we can't simplify it further. Now, the last example here is known as aluminum carbonate. I want you to pay a little bit more attention because it is slightly more challenging. Now, aluminum is a group 3 metal, so the charge of its positive ion is aluminum 3+. Now, carbonate is a polyatomic ion. And for a polyatomic ion, it means that it's an ion that's made up of more than one atom. And in this case, you're supposed to remember it is CO3 2-. Alright, so the 2- charge refers to the whole CO3 group here, total 4 atoms. To get to the final answer, we do the same thing just like the previous 3 case. So we put aluminum Al and CO3, the subscript there. And then we circle the number from the charge here, do a diagonal translation. So aluminum will be 2. And what about CO3? It will be a 3 here. However, because this is a polyatomic ion, you realize if you write this way, it's very confusing. So all chemists will do this. They will put a bracket, alright, to surround CO3 to show you that there are 3 carbonate ions over here. This will then be the formula of aluminum carbonate. Now, with these examples given to you, it will allow you to come up with all the correct chemical formula, whatever ionic compounds given to you in terms of their chemical name. Alright? I hope you find this useful, and I look forward to having you to look at our videos. Thank you.